Hello, ma'am. Good evening, ma'am.
Yeah, good evening. So, as per our schedule, we have discussed two examples, two test bench architecture in UVM, right? Whole TB. One is from adder, one is from counter example. So, do you have any doubts from that? As per our curriculum, we need to discuss three designs in UVM. So we need to discuss last one design, finest FIFO memory, right? So today we will discuss on FIFO memory, whole test bench architecture in UVM, and next session we will complete whatever the leftover topics or their reporting mechanism and virtual sequence concepts are there, right? Next Thursday session we will complete that, and Saturday session we will discuss AXI protocol, and mostly Sunday or Tuesday we will complete second session on APB AXI, not APB, AXI. Okay. So by this Sunday or next Tuesday, so these UVM sessions are going to be completed. Okay. So, do you have any doubts till now, whatever we discussed from assignment or last two designs? Do you have any doubts, everyone? Guru Shant, do you have any doubts? Karar, after long time. Pranay, Tamanna and Vinita, Vishal,
No, ma'am.
Sheetal, Shruti, Yashas, Shamim, Selvakumar. No doubts, huh? Are you practicing the assignment? Now there will be no assignments because in final stage you need to create your own devices. Already we have completed two designs perfectly with the coverage and assertions also, including coverage and assertions. Okay, so today we will discuss on third design. So I think almost 90% you may got the clarity on UVM, how to design whole test bench architecture and what is the flow we need to follow. First we need to start with the interface block, then sequence item, sequencer, driver, and the virtual interface we need to connect, and monitor, driver, sequencer, and the monitor we need to connect in the agent, whether active agent or passive agent, monitor to scoreboard or coverage report, and top level environment we need to design, and that top level test we need to design, and then test bench top. So I think everyone got the clarity. So once we declared all these things internally, first step we need to do is like class. We need to take the class name extending from the parent class, and then factory registration. If it is a object, you need to register with the UVM object util. If it is a component, you need to register with the UVM component util. And second step is constructor. You need to write the class constructor, same as a system verilog. And remaining all are based on phases, what phases you are using. If it is not phase, because in objects we don't use any phase, right? Like sequence item and sequence, we never use the phases concept. We have the transaction flow, right? We use the transaction flow. Suppose the sequence means we use the main body task. In the main body task, we need to write the four methods: initiating the transaction and randomizing the transaction, item done. These things we need to write. In the same way, sequencer is by default will be having the functionality in the sequencer because it's a mediator, right? Sequence item same as the system verilog, however defining some transaction data we write in the sequence item. So I think up to here everyone cleared. Coming to the driver, in driver also, driver is a component. We need to create the class name, and the component utils macro we need to write, and the virtual interface we need to create. TLM ports. In driver, we don't write the TLM port. And we need to create the class constructor. And build phase, we need to write the build phase, run phase. Within the run phase, we will send the transaction data to DUT data. And if you want to write end of elaboration, you can write or else no. Okay. And coming to the monitor, just reverse operation of driver. These three things we can connect in the agent. You can consider either active agent or passive agent. That thing you can configure in the configuration DB. In the last counter example, we have seen how to put active agent, passive agent, and how to enable or disable the coverage or scoreboard. We have seen these things in the last counter example. Like that, what are the leftover topics like info statements? Mostly we will write the info statements or fatal error statements, warning statements as per the requirement. So directly the statements will be printed at the output side. And remaining scoreboard. Scoreboard logic you already know, same as a system verilog scoreboard logic, and coverage also same as a system verilog. Remaining test. In the test we will connect environment. Okay, environment and the interface block, not interface, just environment we will connect. In environment we will connect the agent plus scoreboard. Okay, like the test bench top level. Today we'll see another example also, FIFA example. You will get more clarity. So design part for FIFO, we already I have already explained several times. Several type of designs we have used, right, from starting onwards in Verilog system Verilog. 2 to 3 types of designs we have seen. Okay, so you can prefer any of the design, whatever the perfectly implementing. I already told you, whenever you are writing some UVM test bench, first confirm the design with a Verilog test bench, a simple Verilog test bench. Just write and check whether output is getting correctly or not. Okay, once cross checking that, then start with the UVM test bench or system Verilog test bench. Okay, don't directly write with system Verilog or UVM, because as you are a fresher, sometimes you may get confused whether it is getting error issue from test bench or design, like that. Okay, sometimes even if you don't have any errors in synthesis, okay, I mean in design, sometimes we may not get the proper output, right? Maybe test bench issue also may be there. Okay, so that's why confirm with a simple Verilog test bench first, and then start with the system Verilog or UVM test bench. Okay, so coming to the, I'm not explaining full program for a FIFO, because you already know write pointer, read pointer, declaring the memory, uh, 7 down to 0 and 7 down to 0 bidirectional, and initializing the FIFO memory. Always at the rate of passage clock and reset. If reset is high, for 0 to less than 8, that means 0 to 7, initializing all inputs and outputs with a 0. Memory of I equal to 0, data out equal to 0, write pointer equal to 0, read pointer equal to 0. First of all, what is meant by FIFO? FIFO means first in, last out. First in, first out. Here is the memory. Locations 0, 1, 2, 3, 4, 5, 6, 7 number of locations. Whatever we kept first location, will retrieve in the same way. These all are sequential access. Sequentially, we need to put the data, I mean write the data or read the data. We have random access memories also. Those are RAM, ROM. but sequential access memories are FIFO, LIFO. Okay, so the pointer, the right pointer will be started from 0th location. Okay, so from 0, we are storing some data in this 0th location, and 0 plus 1 first location, and 1 plus 1 second location we are writing some data, and 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, like that, on one step, plus 1 plus 1 plus 1, by using the counter logic. Okay, so after writing the data, same way we retrieve the data from 0th location, first location, second location, third, fourth, fifth, sixth, like that, till 9 and 7th. Okay, so what are the expressions we need to use to write the data and read the data? Write and read expressions are common for any type of memory. Okay, can you tell me what are the two expressions we use to write the data and read the data? Hello, are you there?
Expressions in the sense.
In design, how can we write a logic to write the data into the memory? How can we write a logic to retrieve the data from the memory? That means read operation, write operation and read operation. What is the logic? Suppose
For
multiplexer is there,
writing,
array.
for
Suppose
writing mem of inside that square bracket, we need to put our right pointer. So mem of right pointer is equal to write data, and for reading, read data is equal to mem of read pointer.
Okay, suppose here I'm considering this memory name as a MEM. Okay, so how we can write the data? Mem of
Right pointer means some address.
mem of right pointer, that means address. Pointer means 0 1 2 3 4 at locations. To that location, what we are writing? Some write data, input data. That is how we can use the expression. For reading the data, how we will read the data? To the output we'll get the data, right? So read data is equal to, from where we are getting that read data? From mem of read pointer, right? So these are the two expressions we need to follow. For any type of memory, it is the same. Okay, so for writing the data to this particular memory, pointer will be 0 1 2 3 4, like that, plus 1 pointer is plus 1 pointer plus 1, it will be incremented. So to every location we are saving that data, I mean storing the data. That is write operation. Reading the data means whatever is we have stored in, suppose here in first location I have stored 10 data. So memo of read pointer is a 1 first location, so memo of 1. So what is there in memo of 1? 10. So the 10 will be assigned to read data. Okay, like that. Memo of pointer 4, that means fourth location. Memo of fourth location, I have stored 20 data. So this 20 data is will be assigning to read data. So that is how we are retrieving the data from the memory and writing the data to the memory. Same thing we need to write in a design also. If you see here, and also we need to follow full and empty condition. What is mean by full and empty condition? Suppose we always need to check whether the memory is full or not. Why? Because if the memory is full, we cannot write more data. Suppose already till here the memory is full, can we write the data here? If it is full, we can't write, so we need to stop the operation. Like that, if memory is empty at 0th location, the memory we have. Okay, so is it possible to read the data from 0th location? It's not possible, right? So almost the memory is empty. So these two conditions we need to mention in the program. So for write operation, if write enable, WN means write enable, and Right enable is high, and FIFO full, I'm sorry, full is not. That means full is a not high. That means 0. Full is not high. Not high means still we have a space to write the data. Okay. Then we are writing the data into the memory of right pointer. Memory of right pointer is equal to data in. Okay. Right pointer equal to right pointer plus 1 for every location. It is incrementing. Okay. Next, read operation. When read enable is high and the memory is not empty, then we are reading the data from the memory pointer to data out. Okay. And read pointer is equal to read pointer plus 1. And two statements to represent full and empty. When we represent a full, whenever right pointer plus 1 is equal to read pointer. Okay. Or else you can write some other statement also. When we call as a full, whenever memory pointer reach to the maximum depth of the memory, that means last location, depth in the sense last location. Whenever memory of pointer is equal to depth, FIFO depth, then it is full. Okay. Whenever memory of pointer is equal to 0, it is empty. Like that also we can write the logic, or else this one is another. Okay, we have multiple ways, you can prefer anyone. Here also I have written a Verilog test bench. After comparing with the Verilog test bench, then only you can write UVM test. Any doubts from the design part? Everyone? Any doubts? No?
No, ma'am.
Okay. Coming to the UVM test bench. Here I'm not using any coverage because before two examples we have used the coverage configuration DB separately and assertion also. Okay. So first coming to the interface block, name of the interface is FIFO if and passing the variable same as the system Verilog interface. However, we designed in a SV test bench same, and variables must be declared with the logic data type. We need to avoid the procedural or continuous assignment like a region wire. So we just put the logic. And two clocking blocks. You already know why do we use the clocking block, right? And why inputs or output here and outputs or input in driver, and why all inputs or all the signals or inputs in the monitor. Okay. Next, to mode port. We need to write the mode port. One mode port is for driver. Second mode port is for monitor. Directly we can include this clocking block here, or else you can mention input and input lock and reset also. Okay. After writing interface, you need to write sequence item. Sequence item means transaction class. Okay, even for system Verilog or UVM follow the same. Sequence item means transaction class. So class sequence item extends UVM sequence item, and declare the inputs as a rand data type. Outputs no need to declare. And function new constructor. All the variables you need to declare as object. UVM, because the sequence item is an object, right? So UVM object utils begin inside that all the variables. Variables must be declared with the UVM field int type. Okay, all bit, byte, real, string, all these things comes under int. Okay, so commonly we use UVM field int. Okay, next session you will get more clarity because we will discuss clearly on a reporting mechanism. Okay, next constraints. What is the constraint here? Read enable must not be equal to write enable. That means both are not high at same time, or both are not 0 at the same time, because write and the read operation we cannot do at the same time, right? Once write is completed, then read will be enabled, then we can do the read operation. Okay, next, for data input inside, we are generating particularly 0 to 50 only. What is the size of data we have considered here? 7 down to 0. 7 down to 0 means 8 bit. 8 bit means 2 power 8 number of locations we can use in a memory. Okay. But in the 2 power 8 number of locations, we are storing the data between 0 to 50 locations only. Okay. We are not using entire memory. And this is a function string is just to print the statements, to print the info statements. Okay, just go through that. Next, coming to the sequence. After writing sequence item, you must write the sequence. In the sequence, we will write the main transaction flow and the test benches, test cases. Okay. So if you see class base sequence extending from the UVM sequence, and also it's a parameterized class, so we need to pass the parameter and we need to declare it as a object utils, UVM object utils, and function constructor virtual task body. In the main body task only we need to write the flow, right? UVM info statement we are writing up. What is the UVM info statement here? Get a type name comma dollar format f generate 16 write request. UVM low priority. Low means it's a verbosity level priority. If you put a high, it's a high priority. Medium means a medium priority. Okay. And the repeat of 8 begin request is equal to creating the request here, because request is a transaction item. It's a transaction instance. Okay. Through the request only, we are able to send the transaction data. It's an instance. Okay. However, in system verilog, we create as a transaction tr, t1, t2, t3. All those are objects, nothing but instances. So here also request is a object or instance. Start item of request, assert request dot randomize with write enable equal to 1, making write enable equal to 1. Next, finish item of request. Next, we are writing the UVM info statements. Just go through the UVM info statement. 16 read request. This is for read operation. And next one is for write enable equal to high write operation. Another is one read enable equal to high read operation. Next, total randomization. According to the data, we have taken 0 to 50, right? Using the inside constraint. So by using that constraint, here we'll be writing the data. Okay. So that is what sequence. Next, any doubts still here? Anyone? Any doubts?
Here, what is that assert do, ma'am?
Assert in the sense it's the same as if else, but it will check according to your randomized statement with respect to the clock signal. Immediate assert. Assert in the sense just high, it make trigger at that point of time. Did you understood? Immediate trigger we can tell. If suppose if else means what, if the condition is high, then we'll get some statement, else some fail statement, or pass or fail we will get, error statement we will get. But assert means at this point, at particular point of time, immediately it just trigger. That's what we call as a assert.
From here, assert verifies that statement, or it is used for triggering, like
It
rn
just
is equal to
triggers the
1, like that.
statement. Assert, request, or randomize. Whatever we are telling that within the statement, it just do that. It just trigger that. Request dot randomize. That means that request variable will be randomized with by using inline constraint. If else means it just check the statement. It do the randomization and it will check whether the statement is correct or wrong. Either if or else statement. Both statements will be executed. But assert means we don't write any else statement. It just trigger at that point of time. We don't check the condition. We just do the operation.
Okay, ma'am.
Just a second. Okay. So next, after sequence, we need to write the sequencer. Sequencer is just a very simple logic. We just need to create the class and write the constructor. Even this also not required, but by default we need to use the build phase, right? Because we need to create the components there, all the components. So if you want to put the build phase, you can put, or else you can avoid. That's not a problem. But majorly you need to write the class name, UVM component name, and class constructor. Okay. Next, driver. So in driver, we need to write class driver extends UVM driver with a parameterized name, sequence item, the transaction name we need to pass here, and driver is also a component. Only this base sequence and sequence item, only these two are object. Even sequencer is also a component. Okay, driver is also remaining all our components. So in components we can use the faces, but in objects we can't use the faces. Okay, creating the virtual interface. You already know how to create the virtual interface. And function new constructor and function void build face, super dot build and config db. You already know how to use the config db and main run task. So in run task, transaction flow we need to follow from sequencer to driver. First, request. Request means creating the transaction instance. Next, uh, get next item, getting the data. Sequence item port dot get next item of request. So you need to check which type of TLM port it is. Okay. Next, if write enable is high, then write request dot data in. Else read enable is high, read. This for task. Okay, and sequence item port dot item done. After all the transactions completed, we need to enable the item done. It totally depends how you are writing the different styles. Okay, so no need to follow only single style. You can write in a different ways. Okay. Next, sequence item dot, sequence item port dot item done. Next, main write. So whatever we have written, the main write task, passing the data in, because here argument we are passing input argument. So that's why we have passed the data in here. If write enable is high, then this task will execute. If read enable is high, then this task will execute. Or else if you want to write at some point of clock edge, at some positive edge of the clock, if you want to enable the write, then directly in the main task you can enable and do the write operation. After that, next positive edge of the clock you can do the read operation. But as write and read are dependent here, we can use in this way also. Okay. Next, virtual task, write enable equal to high. If write enable equal to high, we can do the input, data input we can send. So to the virtual interface main data input, that means to the DUT we are passing the transaction input D in. Next, here why only D in reg dot D in we need to put I mean request dot D in we need to put. Okay, we will check. Next, write enable is equal to 0. Whenever write enable equal to 0, then main read task. So here read enable is high. So whenever read enable is high, we can read the data. How we will read the data? From the DUT to monitor, we need to read the data. So next to positive edge of the clock info statement, virtual interface RN is equal to 0, read enable equal to 0. That means in that particular time we already read the data. After reading the data, we are making RN is equal to 0. Okay. Next term, monitor. Any doubts in driver?
Ma'am, where we enabled our write statement.
Where we enable the write statement. Here, see, VIF dot
Okay, okay,
WN
ma'am.
is equal to 1. Then we did the passing the input to the DUT. Write enable equal to 0. Then read enable is high. After in this particular positive edge of the clock, we read the data. That thing will be happened in the monitor. And then we are making the write enable as a 0, disabling the write enable. Okay. Next, go to the monitor. Class monitor extends UVM monitor, UVM component utils monitor, and writing the analysis port here. You already know why do we write the analysis port. Next to virtual interface, we are creating and you are writing the monitor item. That means transaction. Sequence item is a transaction. For that, we are writing MON item. Before in a sequence and the driver, we have written REQ request. So same here also we are writing monitor item. Next, creating the function class constructor. Here is the build phase. You know how to write the build phase and get the data from the config db set method and the get method. So here we are using the get method. Next, in the virtual run task, in the main run task, we are creating the request. That means monitor item. In driver, we kept a request, but here we are putting monitor item. Next, forever, next positive edge of the clock, we are writing the right side one is a DUT data. DUT data is sending to the monitor data. That means reading the data. Okay. Whenever write enable is high. Next, these all are info statements. You can write info statements as your wish, and read enable is high. When read enable is high, we are reading the output data. enable, and empty output data. Okay, write enable is high means input data, read enable is equal to 1 means read data. And next, item collect the port dot write of monitor item. Write method we are using to transfer the data to scoreboard using analysis port. Is it clear, everyone? Any doubts still here?
No, ma'am.
Okay. Next, we'll write the agent. Class agent extending from UVM agent, UVM component utils. For sequencer, driver, monitor, these three will keep in the agent, right? Agent is the top level of sequencer, driver, and the monitor. So we need to keep these three here. And function new constructor we need to write, and build phase. So if you see here, if get is active is equal to UVM active, where we write this thing in the configuration database. Okay. So if get is active is equal to UVM active, we can connect the driver, sequencer, and the monitor. If it is a passive, we need to connect only monitor. Okay, just monitor the data. It doesn't drive the data in case of passive. Okay, so here it is a active. So we are writing here, we are creating driver sequencer. Okay, so if it is active, then connect the driver sequencer, else connect the only monitor. Okay, next connect phase. So how we are connecting driver to sequencer. Monitor to scoreboard we will connect in the top level environment. Why? Because scoreboard is outside the agent, right? So that's why in the environment we will connect a monitor to scoreboard. And also if you write separate file for coverage, we include the coverage also over there. Okay, so this is how we can write the agent. Clear, everyone? Any doubts?
Ma'am, in driver block, I think we should do some small correction in that. Instead of D in, we need to include our sequence item variable.
Instead of D, na, where
We have some, uh,
here
we, yes, we
sequence
declare the
not
instance of our sequence item,
request,
reg. So reg dot D in.
request req dot
Ah,
din.
like,
No, but ma'am, it's we are passing that in when we are calling the main write task, right? We are passing that request or data in, and our input to the main write task is the D in. So I think D in is fine. Yeah, the line number 24. You're already taking care of that request or data in,
Okay.
and the D in is the internal variable to this main write task. So should be fine.
Okay. So here already we have declared request dot data in. So that's why we need no need to pass here as a request. Okay.
okay, ma'am.
Next, coming to the scoreboard. Class scoreboard extends UVM scoreboard component utils scoreboard. Here we are using UVM analysis implementation port. So here we are passing the sequence item comma scoreboard and item collect export. So here it's a continuation to analysis port. Here in analysis implementation name we are taking as a item collect export. Okay. Next, int expected data q dollar. Next sequence item, we are creating the sequence item name here as a COV data packet. Before we have created in driver as a REQ. In monitor we have created as a monitor item. In scoreboard we have created as a COV data packet. Okay. Now we are writing as cover groups here, coverage. Okay, before example, we have written coverage separately, but here we are writing in the same file. Coverage, FIFO coverage option dot per instance is equal to 1. That means every instance we need to check, every bins we need to check at the output side. Okay, so data input, for data input we are writing cover point COV data packet dot data in. For data in we are writing the coverage. Okay, so total 8 bits. 8 bits means 2 power 8. What is the value of 2 power 8? What is the value of 2 power 8?
250.
256. So here we are covering all bins maximum 0 to 256. But in constraints, what we have written only 0 to 50. But does it cover 0 to 255 here? In this case, what would be the coverage? Can you tell me? What is the coverage percentage?
20%.
20%? Why? Why only 20%?
Because we get up to 50 only. And we have the bins count nearly 256.
Okay.
So
Again,
50
okay.
is the 1/5 part of the 256, right? So nearly 20% for that
Is that
power data packet.
okay? Fine. Is that correct from others?
Yeah, yeah. For the
Yes.
first one, I mean, it will cover as we have made the constant 0 to 50, but we have the 0 to 255, so it will cover till 0 to 50 only. So it will be around 20%.
No, wrong.
From 50 to 255, 51 to 255, it will be 0, right?
Okay. I
It will
just
not
need
hit.
coverage percentage. In the last session also we have discussed
It'll
coverage.
hit. It'll hit that bin because 0 to 50 is there within 0 to 255.
Okay. How much percentage do we get?
You should be able to get 100%.
Yeah, you'll get 100%.
Okay. Fine. We'll see. Next, for write. For write command, cover point and bins 0, 1. And for read also 0, 1. And for empty also 0, 1. And for here also 0, 1. And cross coverage also we are checking here. And function new constructor creating the mailbox. Mailbox in the sense TLM port. And in the build phase, just creating the build phase, we are not getting any config data here. And in the write, because here we are using analysis port, right? So by using write method, we just kept the data into the mailbox. Here also we need to use the write method. And also we are creating the request for this coverage packet. And whenever you are creating the coverage, we need to use this method, sample method, then only we can run the coverage. And queue, here we are using the queue to store the data, because we need to write the golden reference values, right? Reference logic you need to write. So to compare the actual output and this output, what we need to do, we need to create a memory, whether you can create a queue or normal memory. You need to store the data there, and then you need to do the comparison. Okay. So if expected data q dot size is greater than or equal to 2, then expected data is equal to we are passing the pop friend data to expected data, each bit to bit we are passing here. And then when read enable is high and the data out request dot data output, that means transaction data is equal to expected data. Then both are match. If request data out is equal to expected data, then both are match. That means test passed. If both are not equal means not match. Test is failed. Okay, we get the error statement here. Next, display the overall coverage. These are for coverage purpose, coverage point of view. Okay. So this is how we can write the scoreboard. Everyone clear? I will explain this one also. Everyone clear till here?
And
Hello.
I have so the data 0 down to 255, it's the data pointer or the value of the data?
The value of data. Data
Okay.
input value. Input value we have taken here as a constraint in a sequence. In sequence item as a 0 to 50. Someone told we'll get the coverage as 100%, right? That is correct. Why? Because this 0 to 50 within here we have written only one bin. One bin 0 to 255. In that bin, even it cover at least one bit or number of 10 number of bits or even 20 number of bits, whatever it is covering, we'll get 100% coverage. Okay. Suppose if you write a different bins, suppose for 0 to 50 one bin, 50 to 100 second bin, 100 to 150 third bin, 150 to 200 another bin, 200 to 255 fifth bin. Like that, if you create 5 bins, then you will get the percentage as a 5 by 1, because in that whole number of bins only one bin is hitting. Number of hits, it depends. Maybe it may have any number of hits, but it is hitting only one. Okay. So we'll see the output and we'll see this condition also. Next, after scoreboard environment, everyone understood whatever I said now?
Yes.
Next, coming to the environment. In environment, we need to connect the top level of agent and scoreboard. So UVM component utils, agent we need to create, and also scoreboard we need to create. Class, constructor, function void, build phase, and connect phase. In the connect phase, we are connecting the scoreboard and agent here. Okay. And next, test. Test is the top level. Same. Test also same. We need to create the sequence, because in the sequence will be there in the test only. Test and the environment we need to connect here. Constructor, build phase, run phase. Here we are writing phase dot rise objection, phase dot drop objection. I will explain that thing clearly on Thursday. Okay. UVM top print topology. Maximum on Thursday, I will tell you whether I can take the session or take the session or not. Maximum 99% I will try to take the session. On that same day, we have our housewarming function, but housewarming function is at 4 a.m. Thursday 4 a.m. I will try maximum 99%, but if I am not available, we can continue on Sunday. Extra session I can complete on Sunday. Okay.
Okay, ma'am.
Next, testbench.sv, top level. In this top level, we are connecting, we need to import UVM package, because all the predefined libraries available in this package only. Next, include these macros and interface.sv and package.sv, because interface we need to connect package in the sense, whatever here we are keeping, including the sequence item, base, sequencer, driver, monitor, scoreboard, agent, everything we need to include here. Okay, so that's why package is including here. And module test bench top bit clock reset we are declaring here, and always clock generating with always block. Next, initial begin, creating the virtual interface in DUT, connecting here, and main DUT, connecting with the design and test bench. You already know here we set the configuration database in the UVM root. UVM root is the main parent to remaining all classes UVM libraries. Next, test is running from the testbench.sv, because lower level blocks need to run from top level only, right? So that's why here we are running. Okay. So that's it. Run.do files is for coverage report. Any doubts still here? Everyone gone through the AXI protocol I have shared for APB and AHB. If you are not aware of APB and AHB, just go through the sessions, and for AXI, just try to understand what are the different types of channels. Okay, what is meant by write channel, read channel, write address, write data, read data, and response channel. 5 channels will be there, right? Try to understand that 5 channels and burst transfers. Okay, remaining all we can discuss in the session. Out of order transactions, burst transfers. Okay. So if you see the coverage, and we'll check the output first. Overall coverage is 100% here. 100% coverage. And
I
for
just
this,
missed. Sorry, how do you run these programs on the EDA playground?
Here for UVM, here there is a language and the libraries, right? Select a system verilog or UVM. And here in UVM and OVM, select a UVM 1.2. And in tools and simulators, you can select either All-Deck. All-Deck is a free access for everyone. If you have your office mail ID or student mail ID, which is official mail ID, if you have, just you can select Cadence, Siemens, and synopsis also. Okay, after that, here for coverage purpose we are using the run.do file, because these are the script commands we need to pass to get the coverage report. These commands will be different for all the tools. Every tool have separate commands. If you go to industry, they will have separate commands to upload the data and to extract the coverage report. Okay, so for EDA playground, especially for All-Deck tool, these are the commands. Okay, so that's why here, as you are using run.do file, click on use run.do file. If you are opening the waveforms, then you can click open EP waveform. And here download files after run. Even you can download the files after run, because to check the coverage report or to check the output statements, that time you can download files, even it is a coverage or not coverage. Okay, So after click on this run option. Okay.
Thank you.
So after run, I will get lot of data like this. Here is the hierarchy. So what is the hierarchy here? First test top. Within the top we have environment. Within the environment we have driver, monitor, sequencer. Within the driver, two ports are there, response port and the sequence item port. Within the monitor, item collect port. Within the sequencer, these are all different blocks. Like that scoreboard we have different blocks. Okay. So in the driver, first if you see generate 16 write requests. So here we are generating 16 write requests. Write enable is X. After some time, 1 full equal to 0. Full equal to 0 means what? We can write the data. Whenever full is high, then only we cannot write the data. So data n equal to 50. Like that, go through these all the statements one by one. Write enable is high. Check every statement one by one. I already shared these links to everyone. Read enable equal to 1. So what is the data out? Read enable equal to 1, empty equal to 0, then data output equal to 50. So here not match. Expected data is 10, got data is 50. So check why it is getting that error. And here also not matched. Expected equal to 10, got equal to 0. Here also expected equal to 10, got equal to 26. For all it's getting same. Huh? Match. Here we got match. And here also match. For match, data equal to 0, data n equal to 0. Here also match case. Here also match, data in equal to 48, data out equal to 48. That statement working correctly. And then here also match, data in, data out. Both are 25, 25. Here not matched. Total 87 info statements. There are no errors, but sometimes it is mismatched, sometimes it is matched. Okay, just check the functionality where it is mismatched and try to but don't make any changes in this code. You can copy this code to your playground and you can use. Okay, don't make copies here, any changes here. Okay, just monitor the data here. And then coming to the coverage report, here for data in we got 100% coverage. How many maximum bins are covering? 18 number of hits we are getting. Even at least one hit you got, that will be fine. Okay, at least one hit. Also you will get 100% coverage. But here we are getting 18% coverage for data in. For write command also same. For all 100% only, but here I'm writing before I said, right, I will take the more number of bins, so max 1, max 2, okay. So here I am removing 255, so 0 to 50. Next, instead of 0 to 50 I am taking 0 to 49. 50 to 99, 100 to 149, 150 to 199, 200 to 255. So these bins we are taking. and the constraint we have written as a 0 to 50. Okay, so based on that, how many number of value we have two chances. Bin 1 and bin 2 will hit. Bin 2 also very rare, only 1 bit chance is there, right? 50 bit. So very rare. Maximum bin 1 will hit. Okay, but we'll see what bins will be hitted here. See here how much bins. Yes, 5 by 1 or within a 5 only one has covered, so in 100 total divided into 5, right? That too in that only 1% got hit, so 20% in 100. Okay, so how many number of hits in 73 point here we got coverage point 20%, and 18 number of hit, remaining all are zeros. This is 73.33 is a overall coverage. Okay. For data input, we got only 20% coverage. Okay. Same thing in real time also. We need to understand in same process. Actually, what is meant by coverage? Through the coverage, we need to check whether we have covered all the scenarios or not for the functionality. Okay, in the coverage report, we will get to know which scenarios we haven't covered. Based on that, we need to check what test case we can run to cover that particular bin. Suppose here bin max 2 is there. In max 2, what are the test values, test scenarios we need to cover? 50 down to 99. So to cover this 50 down to 99, you need to check that related test case. Okay, if that related test case is passed, then only this particular bin will be covered in the coverage. Okay, and same max 3 is there. In the max 3, what are the scenarios we have? 100 to 149. So this 100 to 149 is not covering, in the sense there is no particular test case related to that, or that particular test case got failed. If the test case is failing, we don't get the coverage report for that. We don't get the coverage hits for that. Okay, whenever the test is passed, then only we'll get the coverage. That means we have covered the test. That is what it representing. Okay, so here we got only 20%, means what? Only one test is covered. The remaining 4 tests are not covered. Okay, we need to check what are the 4 tests are not covered. First of all, we need to write those tests. We need to uh, do the functionality. We need to complete the verification for the test, then upload the coverage and check the coverage here. So whenever the bins are hitting here, we are covered that particular scenario, then 100% coverage report will be getting. Whenever you covered all the scenarios, if you don't covered all the scenarios, we don't get the coverage report 100%. If we don't get the coverage report 100%, the design is not verified completely. Okay, even 99.9% coverage also not acceptable. You need to get 100% coverage, then only our design functionality got verified 100%. Okay, otherwise maybe some tests are not verified. So to improve the coverage here, what we need to do in real time, you need to check that particular test case. If it is passed, still if passed, sometimes it may not hit in the coverage, maybe due to some internal errors like coverage side issues may be there, or coverage enable, maybe it is not enabled to that particular test case, or we have missed some commands. Those will be some issues regarding the coverage upload or extraction side. Okay, or else the test case may be failed. If the test is failed, then also we don't get the coverage. Okay, so here what we need to do, actually we didn't took that particular test cases to verify these scenarios. Okay, so we need to write the test to verify these scenarios. Already we have written the coverage, right? In the same coverage we can take the extra scenarios to hit those particular extra uh, values to hit those coverage. Suppose inside 0 to 50 is there. I'm taking another constraint. The inner inside here I'm taking suppose 55 to 90, and here I'm considering 200 to 250. Okay, so maybe now 3 scenarios will be covered, but still we don't get the 100% coverage. We'll see. Number of hits is 0 now. All are 0. By constraint D1 data in immediate assert request or randomization failed. Okay. Now we got 60% coverage. 3 bins are covering. I took 0 to 200. In that 0 to 200, bin 1 is covering, bin 3 is covering, and bin 4 is covering. That means between 50 to 100, no values are generated. And here also no values are generated. So in this case, what we need to do, before in the first session itself, we discussed to have the more good coverage, yeah, we need to take the multiple constraints, like small constraint, medium constraint, and a large constraint, or else for data input one constraint, write transaction one constraint, read transaction one constraint, we need to take. Okay, so in that case we will get the proper coverage report. Okay, once check that thing, and before also we got some error for assert, just check that error also. Okay, if you don't get, then we will discuss. Clear everyone? Any doubts still here?
Uh, Prashanti, one doubt actually. Here we just have one test, and we updated the sequence to cover more data in values. So how can we actually control? Suppose we want to have multiple tests, and through that we want to change the data in values, like a constraint for the data in. Is it possible that so? Like
Through the
the test one, through the test Like the test one might tell,
no,
okay,
we can
data
write
in
the
should.
test. Yes, we can write the test. Number of test cases we can write.
Yeah, but how to control the sequence item data through the test in that case?
Through the tests.
Yeah.
Here only we will create, suppose sequence item is there, this is one test, this entire thing is one test. Like that you can create a sequence item 1, class sequence item 1, that is second test,
Okay.
class item 2, that is second test. And here in this test we have declared data in data, all these things, right? If you extend the same class sequence item
Hmm.
sequence item 1 from this UVM sequence, then again here you need to declare all these rand input, all these things again you need to create the class constructor, you need to do like this. But if you extend this sequence item 1 from the parent class sequence item, this sequence item, then child class can access these parent class properties, right? Then you no need to write declare all these things directly, you can create the class constructor and you can write these constraints.
Secret
That is how
constraint.
we'll
Okay.
have that is how we'll have number of test 1, test 2, test 3.
Okay.
Like that also you can write in test 1 some scenarios you can cover, in test 2 some scenarios, like that.
Okay.
Just try to get the 100% coverage with a multiple test, not like this, not single test, with multiple tests. Okay, that is what the assignment for today. Any other doubts? Others? Karar, did you understood the session today?
Yes,
Pranay?
ma'am. Like I need to go through it again.
Okay, Pranay? Remaining, Vishal? Remaining all are regular students only. Sheetal joining regularly. Yeah, Yashas also joining regularly. Vinita joining regularly. Shamim, Karthi, KV. I think from last few sessions I didn't saw his name. CB is very regular, very punctual, and also very active in the session from starting day
Thank you,
one
ma'am.
onward. Yeah. Okay. Any other doubts? Okay, then just practice till here. We will discuss in the next session. Okay. Thank you all. Bye.
Thank you, ma'am.